The first exercise, number 1, if the two roots of the equation 4x power 2 minus 4x power 2 minus 12x plus c equals 0. If the two roots are equal, if there are two equal real roots, then c equals what? We know that if the two roots are real equal roots, that means that discriminant equals 0. We can say that d equals 0. db square minus 4ac equals 0. Here we can write that a equals 4, b equals negative 12, c here equals c. We can substitute here. B square negative 12 square minus 4, b square minus 4ac equals 0. b square negative 12 power 2 minus 4 times 4 times c equals 0. 144 minus 4 times 4 equals 16c equals 0. 144 equals 16c. We divide by 16. 144 100 here divided by 16. 144 divided by 16 equals 9. C here equals 9. If x equal negative 1, x equals negative 1 is one of the roots of the equation x power 2 minus ax minus 2 equals 0, then a equals space. X equals negative 1 is one of roots of the quadratic equation x power 2 minus ax minus 2 equals 0. That means that if negative 1 equals 0, if you put x equal negative 1, if you substitute by negative 1 inside the equation, you will get 0. If negative 1 equals 0, x power 2 minus ax minus 2 equals 0. Negative 1 power 2 minus a times negative 1 minus 2 equals 0. Negative 1 power 2 equals 1. Negative a times negative 1 equals a minus 2 equals 0. 1 minus 2 negative 1. A minus 1 equals 0. That means that a equals 1. Here a equals 1. 1 is the right answer. Prove that the roots of the equation 3x power 2 minus 4x plus 5 equals 0 are not real. The roots are not real if the discriminant smaller than 0. If discriminant smaller than 0, b square minus 4ac smaller than 0. That means that there is no real roots. B square minus 4ac, here a equals 3, b equals negative 4, c equals 5. Let's substitute negative 4 power 2 minus 4 times 3 times 5, all of these smaller than 0. 16 minus 4 times 3 12, 12 times 5 12 times 5 4 times 3 12, 12 times 5 equals 60. We note here 16 smaller than 60, their subtraction smaller than 0. Therefore the roots of the equation are not real. Then find the solution set in C, in complex number. He wants the solution set in the complex number. 3x power 2 minus 4x plus 5 equals 0. we can't factorize this equation. We can use the general formula x equals negative b, positive or negative, root b squared minus 4ac over 2a equals negative b, negative 4 plus or minus root b squared negative 4 power 2 16 minus 4ac. We can write 16 minus 4 times 3 times 5 over 2a, 2 times 3 equals 6, equals 4 positive or negative. If you want to calculate 16 now we are calculating the value of the discriminant. 16 minus 4 times 3 times 5 equals negative 44, negative 44. 4 positive or negative root negative 44 over 6 equals 4 positive or negative root negative. We can write negative root negative 44 as 44 I power 2, because that means that negative 44 means 44 times negative 1. We can write negative 1 as I power 2 over 6 equals 4 positive or negative root 44 equals 4 root equals 2 root 11, 2 root 11i over 6. The two roots are 4 plus 2 root 11 I over 6 and 4 minus 2 root 11 I over 6. We can simplify the two roots, or we can write the two roots in the simplest form. Here, if you want to put in the simplest form, you can divide by 2 up and down. That means that the first root is 2 plus root 11i over 3, and the second root is 4 divided 2, 2 divided 2, 6 divided 2, or we can take 2 as a common factor from numerator. 4 divided 2 equals 2 minus root 11i over 3. If you want to check your answer by calculator, we can press mode 5, 3, 3 equals negative 4 equals 5 equals then equal x1, the first root, 2 over 3 plus root 11 over 3i. Here 2 over 3 plus root 11 over 3i. X2, the second root, 2 over 3 minus root 11 over 3i. That means that we are correct. If a equals 1 plus root 2i, b equals 1 minus root 2i, then ab. Here ab means a product b, or a times b. A equals 1 plus root 2i, b 1 minus root 2i. Here, if you want to multiply two conjugate numbers, because they differ in the sign of the imaginary part, the first bracket and second bracket are two conjugate numbers. How can we multiply two conjugate numbers? First by first minus second by second. First by first equals 1 minus second by second. If you want to multiply second term by second term, root 2 times root 2 equals 2. I times I equals I power 2 equals 1, I power 2 equals negative 1, and we have negative 1 times negative 2 equals positive 2. 1 plus 2 equals 3. Then AB equals 3. AB equals 3. The simplest form of the imaginary number I power 42 is, we know that to find the imaginary number in the simplest form, we can divide the power by 4. We can divide the power by 4. And look at the remainder. If the remainder in the decimal form 0.25, the answer will be I. If the remainder 0.5, it will be negative 1. If the remainder 3 over 4 or 0.75, it will be negative I. If there is no remainder, that means that the remainder is 0, it will be 1. Let's start by the first one, the simplest form of the imaginary number I power 42. We can divide 42 divided by 4, 42 divided by 4 equals, in the decimal form, the remainder 42 divided by 4 equals 10.5. Look here at the remainder 0.5. If the remainder 0.5, it will be negative 1. It will be negative 1, the first one, negative 1. What about number 3, I power 32? I power 32, we can divide 32 by 4. 31 divided 4 equals, in decimal form, 31 divided 4, 7.75. We said before, if the remainder 0.75, it will be negative I. It will be negative I. Then I power 32 equals negative I. Negative I. The simplest form, if the bracket 1 minus I all power 4, we can write 1 minus I all power 4 as 1 minus I power 2 all power 2 all power 2. 1 minus 2, sorry, 1 minus I all power 2, it will be negative 2I. Negative 2I. Negative 2I power 2, negative 2 power 2 equals 4, I power 2 equals I power 2, 4 times negative 1 equals negative 4, number 1. Again, what did we do? Here we splitted the power 4 into into product of two powers, 2 times 2, 1 minus I all power 2, 1 minus I all power 2 equals the first power 2, 1 plus second power 2 I power 2, 1 is first by second by 2, negative I times 2, negative 2I, 1 I power 2 equals negative 1, 1 minus 1 minus 2I, cancel 1 minus 1 equals 0, it will be negative 2I. We can write 1 minus I all power 2 directly as negative 2I all power 2. We have to square negative 2, negative 2 and I. Negative 2 power 2 equals 4, I power 2. Then find the value of I power 2 equals negative 1. Then find their product, 4 times negative 1 equals negative 4. Simplify 3 minus 2I all power 2 times 3 plus 2I. If you look carefully here, you can find that the two expressions inside the first bracket and second bracket are conjugate. We can split the first power as, if you have a power 2, you can write a power 2 equals a times a. We can write the bracket power 2 as bracket times itself as 3 minus 2I times 3 minus 2I, the second bracket 3 plus 2I. Here the third and the second brackets are conjugate. First 3 minus 2I, we can multiply the two conjugate numbers, 3 minus 2I, 3 plus 2I, first by first minus second by second. First by first, 3 times 3 equals 9 minus second by second 2 times 2 equals 4, I times I power 2. Here 3 minus 2i, 9, I power 2 negative 1 times negative 4 equals 4. 9 plus 4 equals 13. We can multiply 13 by the bracket. 13 times 3 minus 2i. 13 times 3 equals 39 minus 13 times 2 equals 26i. If you want to check your answer by calculator, you can use the calculator by this way. First, you have to press mode complex, mode number 2, the first bracket, 3 minus 2i bracket power 2, second bracket, 3 plus 2i equals 39 minus 26i. 39 minus 26i, it is a complex number. 39 is a real part and the negative 26i is the imaginary part. The second, if bracket r1 plus I power 8 times 1 minus I power 11 equals x plus iy, then x plus y. This exercise talks about the equality between two complex numbers. First, we have to find the left side in the simplest form. 1 plus I power 8. We said before, we can divide the power by 4 and check the remainder. 8 divided 4 equals 2. There is no remainder. That means that if there is no remainder, the remainder equal 0, it will be 1. I power 8 equals 1. The second bracket, 1 minus I power 11. Divide 11 by 4. 11 divided 4 equals 2.75. Is the remainder in the decimal form equals 0.75, it will be negative I. I power 11 equals negative I equals x plus iy. 1 plus 1 equals 2. 2. 1 minus I equals x plus iy. 2 times 1 equals 2. 2 times negative I equals negative 2i equals x plus iy. We say that here, if there are two complex numbers, that means that the real part equal real part and the imaginary part equal imaginary part. Here x equals 2, x equals 2, and y equals not 2, negative 2. Y equals negative 2. He wants x plus y. X plus y, 2 plus negative 2 equals 0. X plus y. I'm sorry, we did a mistake here. 1 minus the value of I power negative I power 11 equals negative I. Here we have negative I and we have negative times negative equals positive. 1 plus I. 2 times 1 equal 2. 2 times I equal positive 2i. I'm sorry. Here x equals 2 and y equals also 2. X plus y, 2 plus 2 equals 4. 2 plus 2 equals 4. Again, 1 minus I power 11. I power 11 equals negative I. And also we already have negative. Negative equals positive. 1 plus I. If one of the roots of the equation ax power 2 plus 2x plus 5 equals 0 is a multiplicative inverse to the other, then a equal, we know that if one of the two roots are multiplicative inverse of the other, that means that absolute term equals coefficient of x power 2. Again, absolute term equals coefficient of x power 2. Absolute term c, coefficient of x power 2a. Here c absolute term and this coefficient of x power 2 a equals 5. A equals 5. If one of the two roots of the equation x power 2 minus bracket m minus 3 times x plus 5 is an additive inverse to the other, find the value of m. If one of the two roots is additive inverse to the other root, that means that p equals 0. P equals 0 means b is a coefficient of x, because we know that the general form of a quadratic equation ax power 2 plus bx plus c equals 0. P here the coefficient of x. What coefficient of x here? Negative m minus 3 equals 0. That means that the value of the bracket equals 0. M minus 3 equals 0. M equals 3. Here m here equals 3. We can choose 3. If 1 plus I, one of the two roots of the equation x power 2 minus 2x plus c equals 0, where c is a real number, find the other root, then find c. We have a remark here. If we are talking about a quadratic equation or second degree equation, coefficients, if all coefficients are real and one of the two roots is non-real complex. Again, if all coefficients are real and one of the two roots, or you can say that the given root is non-real complex, that means that the other root is a conjugate of the given root. Let's apply this remark. If 1 plus I is one of the two roots, the quadratic equation x power 2 minus 2x plus c. What about the coefficients here? A equals 1, coefficient of x power 2, b equals negative 2, and c is absolute term. All of these are real numbers. Here A real, B real, and C, he said that C is a real number. The first condition, all coefficients are real. The second, the first root, the given root here, the given root 1 plus I, here complex. That means that the other root, the conjugate of 1 plus I equals 1 minus I, the other root 1 minus I. Find the other root, then find c. To find the value of c, we know that 1 plus I is one of the two roots. We can substitute by the first root. Instead of x, we can put 1 plus I. Here x power 2, 1 plus I power 2 minus 2x 1 plus I plus c equals 0. You can use your calculator. 1 plus I power 2, but first move to the system of calculator should be complex. 1 plus I, 1 plus I power 2 equals 2I. 1 plus I power 2 equals 2I, minus 2 times 1 equals 2. 2 times I equals negative 2I, plus C equals 0. 2I minus 2I, and negative 2 plus c equals 0. That means that c equals 2. Simplify 1 plus 2I power 3 times 2 plus 3I power 5 plus 4I power 6. 1 plus I power 3 equals negative I. I power 3 equals negative I. Here negative I times 2 equals negative 2I. 1 minus 2I times 2 plus I power 5. You can use your calculator. I power 5. Divide 5 by 3. Here divide 5. 5 divided 3 equals 5 over 3 equals 1 point, divide 5 by 4, 5 divided 4 equals 1.25. If the remainder 0.25, it will be I. 3, the value of 3i is 3i power 5, value of I power 5 is I, plus 4i power 6. I power 6 divided 4 equals 1.5. If the remainder 0.5, it will be negative 1. 4 times negative 1. Here 1 minus 2i. Here 2 plus 3i. 4 times negative 1 equals negative 4. 1 minus 2i. 2, 2 minus 4 negative 2 plus 3i. To find the product of the two brackets, we can multiply 1 times negative 2 equals negative 2. 1 times 3i equals 3i. Then negative 2i times negative 2 equals positive 4i. Again, negative 2i times negative 2 equals negative positive 4i. Then negative 2i times 3i, negative 2 times 3 equals negative 6. I times I power 2, negative 2 plus 3i, negative 2 plus 3i and 7i equals 7i minus 6. I power 2, negative 1 times negative 6 equals positive 6. Negative 2 plus 6 equals 4. 4 plus 7i. Here, critical thinking. If a and b are two negative real numbers, is it possible that root a times root b equals root ab? And explain your answer. We can say that root a times root b equals root ab. These operations on square roots. Root a times root b equals root a times b equals root ab. If that happen if a and b are positive real. An example: root 3 times root 5 equals root 3 multiply 5 equals root 15. But the operations on the square roots are not on the imaginary numbers. These rules of square root multiplying of square roots just only if the numbers under the square root are positive real. But the operations on square roots are not on the imaginary numbers. That means that if you have root negative 3 times root negative 3, and you said root negative 3 times negative 3 equals root 9, and root 9 equals 3. That's wrong. This not equal. But if you want to multiply root negative 3 times root negative 3, like this, root negative 3 times root negative 3, you can calculate the first root and second root as a special case. Root negative 3 means root 3i power 2. Root negative 3 means root 3 times negative 1, 3i power 2. Here, root I power 2i, the first root 3i, the second root 3i also. We multiply root 3 times root 3 equals 3. I times I equals I power 2. 3i power 2 equals negative 1. 3 times negative 1 equals negative 3. If you apply this rule, it will be wrong. You will have 3, but this rule will give you negative 3. Again, we are going to say that the operations on the square roots are not on the imaginary numbers. Just for a and b, just numbers under square roots must be positive real. If you have any question, I have finished. If you have any question or anything you not understand, please leave a comment. Below the video. Thank you very much. Goodbye.